Okay, unfortunately, you're going to have to deal with me here. I'm saying that because this was actually prepared by our good colleague Sagar Aurora. You've heard his name a couple of times. He's online there. He asked me a couple of weeks ago, would you moderate this panel? Because you know a lot of things. Well, I don't know about this particular topic, unfortunately. But I'll do my best here. And Sagar is here. He's on the other end of the world, but he seems to be connected. So the title of this panel is a collaborative open source approach to deploying ORAN. The discussion already started a couple of minutes ago. Really, this is all about SMO, or Service Orchestration and Management, which is, in general, in networks, a very important area when it comes to deploying them, and in particular here for the RAN component. And this is actually something new, I think, at least from an open source context, applying these ideas to the radio access network. And these services, they provide certain interfaces, in particular FCAPs, to the Open RAN or the ORAN network functions. For instance, to the non-real-time RIG for the RAN optimization, and to OCloud for management, orchestration, and management of the workflow. The network function orchestrator and federated OCloud orchestration and management, or FOCOM, those are two important services for orchestrating network functions. And maybe I should go to the picture that Saga prepared here, which shows really the big picture of the framework, where on the bottom right you see everything related to the radio access network itself. But there are all kinds of functions all over there to manage this complicated network. So we just heard about the Nefio project, which is one of the big Linux Foundation projects in this area. And this can actually be seen as enabler for the SMO services. But really, the question is how to make this possible, and that's what this panel is all about here. And also how the different open source communities can collaborate in deploying the ORAN components, which is really the heart of today's of this week's workshop. So what I would like to do here, I mean, Irfan already introduced all the panelists. What I'd like to do now is allow the panelists to give a short introduction on how they contribute to the ORAN and the Nefio ecosystems. In total, around 8 minutes, so maybe 2 minutes per panelist, just to give a brief introduction of what their role is in this story. So maybe we'll start with Azar.
Sure. Thank you very much. I apologize for being late. I didn't expect it. My name is Azhar. I work with Red Hat, and I've been involved in many different communities, including work with OAI for some time. But just to place where Red Hat is in terms of contributing to both ORAN and Nefio. Right from the get-go, I don't know if many of you know a little bit of history around Nefio. Kandan used to be at AT&T when we used to discuss a lot of, how do we use CRDs for network function, descriptions, so that we can actually manage in a standardized way. And Red Hat actually had a capability of Kubernetes operators, and we actually operated the whole platform using Kubernetes operators and using CRDs. And when he went over to Google after some time, and I think they found some similar problems in terms of how they actually run that particular infrastructure. And then of course they had some good friends in the industry, TELUS and a bunch of others who joined hands to say, well, yes, this is a challenge, and we need to actually do something about it. And then the entire initial Nefio conversations came about with a number of carriers, and of course Kandan being one of the architects around it from Google. So we absolutely believe in that particular framework and architecture in terms of what Nefio does. We believe that because primarily, fundamentally, we operate our own platform the same way, using CRDs, using Kubernetes operators, and we actually deploy our own platform. In fact, one of the things that I should talk about I do talk about as part of my presentation right after the panel is around how do you use these different types of operators to do that. Now, what it does is when you have a standardized CRDs, then it allows you to actually create a uniform, a model or a uniform solution around this in terms of deploying network functions and in terms of deploying the infrastructure itself. So Red Hat's been really deeply involved in that particular conversation. And then, of course, in ORAN, I know many of you here are part of the ORAN different working groups, so WG1, WG2, WG6, WG4. All of these are areas where we have actually spent some time initially around some of the timing synchronization work there, and also then around the architecture work. Yes, we don't have any network function implementations ourselves, so we don't get deeply involved into the network functions themselves, which is the RAN CU, RAN DU. But we very much care about the OCloud. We very much care about the O2 interfaces. We very much care about the deployment models. We very much care about the interfaces to SMO, and hence this particular panel conversation.
So I'm David Kinsey. I work for AT&T. I started working in ORAN with Working Group 1. I've maintained that, so I'm involved directly in the SMO decomposition and SMO and intent management and things of that nature. But then as they split Working Group 1 into Working Group 10, I also contributed a lot into the Working Group 10 due to the O1 being there and the information modeling being there. Eventually, I became the co-chair of Working Group 10. At the same time, I was brought into the OSC, and I was the co-chair for the RSAC, and I've maintained that position with my colleague Ritwick, who used to be AT&T and is now Google, through a journey now at Google. And then my boss retired, and I inherited the co-chair of OSC as a result as well. So I also co-chair the OSC. But in terms of time, my large amount of my time in ORAN is actually spent more in developing the O2 interface on Working Group 6. I don't chair it. I am a contributor, so I'm opinionated in Working Group 6. Tim Carey is around here. He'll attest to that. We often have discussions, very good ones, on approach. The goal is always to make sure that we are agnostic. We don't want to, we're very careful from an operator's perspective that we don't want a vendor lock-in. We don't want to be locked into Kubernetes. We don't want to be locked into OpenStack. We don't want to be locked into a vendor for the NF. We want it to be an open architecture that we can freely interchange or interplay when demand arises for any function. And that extends up now with the introduction of XApps and RApps for the network as well, is that we want an ecosystem, so a marketplace where we can go out and get these things from not our traditional equipment vendors, people more in academia and stuff that have done research that have understand not how the radio access does RF transmissions, but what the effect of that is, and how we can optimize that or improve that. And so that's where I spend almost all my time.
Hi, this is Seshu. I've been with LFN from many years, actually, right from the incubation of ONAP to start with. I've been under the AT&T's this thing, or Ecom. I was managing the SO code, which came from AT&T, and I've been the incumbent SOPTL to start with. That's my journey with automation in the ONAP. In the open source, before that, I was part of multiple other things also. And then from there, I'm the SMO-PTL, recently elected again by the OSC team. And now I'm also the part of the TSC of NIFIO. Whether me and Azhar were part of multiple other communities also before. The core of this is the orchestration automation piece, which I've been talking about. I'm coming from Wind River. Wind River is again backed by the open source. It is a company which totally has everything upstream, 100% upstream code, and that is what we even go to commercial. All our scale deployments are actually done with the same code which you see even in the open source itself. We are the company at scale. We're deploying these concepts at scale. Not just about concepts in peer, and as rightly said by Azhar and David, a lot of these concepts are there, which we are trying to take it to market and have it deployed. The other important thing to notice from those three cycles which you saw, right? NIFIO, OSC, and OAI. I've been part of two of the circles deeply involved with NIFIO and OSC, and OAI is actually where, thanks to Sagar, Irfan, And all gentlemen over here who are supporting it, I'm sure we'll also have some contributions which can take into OAI too. So truly looking forward for this discussion. And again, my area of interest is orchestration automation of all these pieces, especially the RAN piece, which is the most complex of all to start with, right? And that complexity, not just because of the involvement, also at the scale which we are talking about. So that is something looking forward to have collaboration with you and solving the bigger problem. Thank you.
So I'm Tim. Yep. So I'm Tim Carey. I work with Qualcomm, and I started with Qualcomm about 2 years ago to actually help them realize their vision of an open RAN. And my focus areas for them was really whether that was through specifications or open source. And my areas in working with them is really through the cloudification, the orchestration areas, as well as the management areas. So in that, I do work in the ORAN specifications, as David had said, both in the cloudification area as well as the OAM, the O1 area, if you're familiar with the ORAN specifications, and some up in the architecture piece. But again, we think that there's a partnership there between specifications and open source. And so, within Qualcomm, we are big supporters of OAI. We think that they've got the ticket for the network functions and opening those up as part of the ORAN. And we also think that the OSC in the work that they do for other functions, particularly as we decouple the SMO, those service capabilities, they're going to play an important part. And so we're very, very much supportive of those efforts. And so as part of that, when we saw the Nefio work that was happening and the fact that they were able to do these deployments, and we're going to need these for these edge sites at scale, it just piqued our interest in that, right? And so we said, well, if we bring these three organizations together and we're able to collaborate successfully, we can realize an at-scale Open RAN. And so that's what our interest in this panel, in this work. And so as part of that, I also work in the Nefio community trying to herd the cats that comprise OSC, OAI, and Nefio in order to realize an Open RAN.
Okay, so thank you very much. That was very informative. So there are a bunch of questions here that Sagar prepared, and we'll go through them one by one. So the first one is addressed directly to Dave Kinsey. So what is the current status of OSC in this area, and what is the relationship between the ORAN specification group and the OSC in this area?
Okay. So the current state of OSC is that we have ODU High and its ongoing development that's in ODU High. It is largely done with RADASYS, but it's also augmented by students out of the Taiwan University. There is we use their binary in many cases, but now that we've cleared the perceived licensing issue of using OAI in some of our labs that are more by commercial companies than they are academia. Now that we've cleared that issue and got a better understanding of the licensing, we feel like that now we can run the OAI CU as an alternative to that. And then what it provides us is now when we look at it as an ecosystem is that we have OAI code for the RAN, we have OSC code for the RAN, we have two vendors, and we can now really start testing interoperability. And so that's really the ultimate goal of ORAN is interoperability. And so demonstrating that is, I think, key to the success of ORAN, and demonstrating that in open source shows that it is possible. And therefore, then now as operators, I switch my hat and become the operator, I can point to my vendors and say, but it's already being done. Why haven't you achieved the same level of interoperability? Because it's already being done. And that's a nice lever to use to try and get the industry as a whole to start to shift to this. Most of the disruptors have already made shifts, but the incumbents are much slower. They're big machines. They're slower to move and change. And just because we talk in standards, it's a whole different organization and product. And so trying to get the product team to then follow the standards is a whole different activity for us. So what was the second half of your question?
Well, the second half was what is now the relationship between the ORAN specification group and the OSC?
So what we've instituted this since Osaka. So we just recently started this. We've had this challenge over the years of gaining. We report to the TSC, and so our TOC has a session on the TSC in ORAN, and we report to them. They fund us, and so we report to them. The OSFG has a much broader view than just the OSC. They're looking at all of the different open source groups and trying to, as Tim mentioned, herd all the cats towards a common goal. And we align with the need for a common goal. The question gets down to execution. How does it actually work? But what we've implemented now is that we largely align with the MVPC. We started with the SMO and now I forget the other MVP, AIML, because we just recently added an AIML project to the OSC, and so it was good to start that project aligned with the MVP C committee for that feature of AIML. But recently in Phoenix, we also included energy savings. It's another new feature coming out in release 4 that is in timely, and so we've been working on with our current release, trying to align with their vision, and at the same time getting the necessary data. Data is the issue for any AIML, and getting a clean set of usable data that is used. So we partnered with NSF to try and get a common data set that's public that we can all use. And so that's what we've been working on. We finally have that data set. BMO from OSC and out of the Taiwan lab is also working with Viavi to generate a synthetic data set. So we won't just have one data set, we'll have multiple sets, so we can see that the AIML isn't contrived based off of the data set.
Okay, thank you very much. So second question, and this is to all of you. Can Nefio be seen as an enabler in the SMO architecture? And if yes, what role will it play?
So, I don't know why that doesn't work, but it doesn't work. So, it's probably operator error. So, if you think about Nefio, and I think Tal said it well, it's the first thing that you got to realize is that Nefio is a Kubernetes-based orchestration system, automation system. So, as David had concerns, it's understanding that it is a Kubernetes base, and it's meant to be used for deployment of network functions at scale, right? So that scale is an important thing because it brings various principles that may not have been done when we were treating our pet ORAN network functions, our DUs and CUs, when we treated them as pets, not as cattle. Right. So when you're deploying things, you're deploying cattle in Nefio, right? You're not deploying pets. And so there's things that would have to change. But the capabilities and the enablers that Tal talked about align very well with the capabilities and needs of various functions within the ORAN architecture, to include the network function orchestration area, the FOCOM area, which does the infrastructure piece, the IMS services, which is deployed in the cloud, and the DMS, which is deployed in cloud. So those functions can utilize aspects of the Nefio enablers to allow for deployment of the ORAN network functions at scale. So it's a very compatible setup, which is what interests us to start engaging these three areas of OAI that does the network functions, OSC that does other functions within the ORAN architecture, and then couple that with Nefio to be able to do those deployments.
I mean, good that I'm speaking second so that I'll have more points. Just to add to what Tim said, I mean, Tim has covered almost everything, by the way, to start with. I mean, the other part is actually the NFO part, which he was talking the IMS. The other part is NFO, because that's where one is, of course, the cluster management is critical. The other part is to add to the getting on the workload, right? I mean, that is more critical also when it comes to the edges and especially RAN edges. So Nefio, I see as the enabler. In fact, the word enabler is actually something which I suggested to add, because when you talk about the disaggregated SMO right now, and with all due respect to David Kinsey, we have been talking about this also. One of the biggest challenges we see is we have references of it across the open source communities, but we didn't find many of them which can work at scale. That's something which we have been looking into. And Nefio, for the K8s profile especially, again, I want to stress on the point, for the K8s profile of the ORAN, I see Nefio is a good fit from the orchestration perspective. And integration of that with the existing OSC components like the INF and the other, we have our friend John Kinney also here, who's actually working on the rig pack. So those components, along with the new added listing on the SMO, it can be enabler for the SMO functionality. That's what we are looking into. So for me, instead of reinventing the wheel, we are trying to find those nuts and bolts, which are all the low-lying fruits, which are actually what we can take, have them all geared up, and then push it faster. So we are actually trying to accelerate ourselves instead of reinventing the wheel and working in silos. And this is great work which we are trying to find here, as the other panelists were also talking about, having multi-vendor, approach, which is actually very critical for us to proceed and succeed. So surely Nefio will be an enabler for us from that perspective.
So I'll take it slightly one step further, I guess, is that, and hopefully my Red Hat colleague will be able to really close out on this, is that the area that's not readily addressed in ORAN is this magic that happens between the rest of the SMO and the NFO FOCOM, and what does the FOCOM actually do with the O2 interface? And the O2 interface is, I would call it version 1. There's no other, it's not even complete yet in terms of the IMS. DMSs are a different story. They're a little more mature because they had Kubernetes and they had Etsy to leverage on, but there wasn't much in terms of the IMS. And this is where we really need where Nefio is really starting to hone in on a solution spaces that do it. And their approach is for using GitOps, but abstracting that so that it becomes simpler to use, because GitOps in a large environment becomes somewhat unmanageable. But if we can do it at scale through abstraction, whether that's through operators or other means, that helps. That makes it simpler for the management aspect. The question will be is that as an enabler, it's not necessarily the interface between the different SMO components. It's something that helps us implement those functions, especially since our first target is really Kubernetes. We can talk about the need for OpenStack. We can talk about beyond Kubernetes, but initially it is Kubernetes. And so we have to keep that real and make it real, because otherwise we get to a point where we're stuck. We don't know the future. We don't know the past that we can dwell on, but the here right now, it's Kubernetes, and it has to work. And so that's where we start seeing some differences, like the repositories and the stuff like that GitOps is using in the SMO needs to somehow be coordinated or integrated with the topology and inventory services of the SMO, so that we can link the data sets together so we understand the relationships. And so that's really the question, and it's not being readily addressed by anything yet. But it's definitely Nefio is filling a gap there, because it's a big void and they're making it a smaller, just the fringes that are needed. What's the binding glue that's needed to connect Nefio as an enabler to the rest of the SMO functions?
I agree with David on a number of points. I think if you just step back a little bit, in the for those of you who have deployed OpenStack and for those of you who have deployed VNFs on OpenStack, you needed a VNF manager. Many times that VNFM came with the VNF vendor, and there were like 5 different VNFs. You'll have a different VNFM for each one of them. And then you had to have the orchestrator now interface with the VNFM each time you wanted to make a change in terms of those VNFs. That was a challenge. So then we created something called a generic VNF manager for those of you who remember Tacker, right? Now, all of those things, if you actually look at it, what was the fundamental problem they were really trying to solve? They were trying to solve in a standardized way, how can you actually manage those NF network functions that are deployed on the infrastructure with lifecycle at scale? And that's exactly where Nefio found that particular sweet spot in terms of looking at it and saying, hey, wait a minute, these are going to be network functions running in containers on a Kubernetes environment. There are a number of things that we need to actually do it in a standard way, lifecycle management of those, start, stop, metrics, whatever that we need to do. Can we actually have a standardized definition on these type of things using a CRD? And can we actually operate them in an important way? So I think that simplification that has happened there is actually really important. And so I totally agree to the points that my panelists made, which is it actually provides that particular binding glue between that what is being deployed on the infrastructure to what the service orchestration layer is. And it's really critical in that sense.
Okay, thank you. So third question, and I think to a certain extent, Dave may have answered some of this, but let's see. What's missing today in the ORAN specifications to address the deployment of the ORAN network functions through the OCloud Kubernetes profile?
I'll start off, and you guys can
Sure.
pitch in. The immediate thing to me is that we've already accepted that there'll be custom resource descriptors that we onboard. So we'll have custom resource operators in the Kubernetes environment. So we've embraced that concept already. But there's a nuance to it. First of all, it's not part of the OCloud. It's not part of the SMO. It's a third-party developed piece of the management that stitches together that which needs to be managed by the cloud as opposed to that which will be managed by the SMO over the O1. So it is really this binding agreement of what has been delegated to the O2 to be managed and what is delegated to the O1 to be managed. And yet we don't have a clear understanding really yet. The CRD is expected to be configured into the cluster. So that's part of the IMS. We're configuring the cloud, the infrastructure. So we configure it. Now, once you configure it, it should show up now as what we call a capability. When we have a new app that comes in and it says, well, I need this resource descriptor, okay, that capability should be exposed by the cluster so that we can do what we call homing and saying that we can put that net function on that cluster because it has been provisioned to support that function. The thing is that how that exactly happens to get from IMS provisioning to the DMS equivalent of the lifecycle operator for the NF is very unclear. It's not specified in the specs. We don't need to necessarily specify the values. Those can be done, based off a delivery, as long as the developer understands the operator they're going to use. There might be some nuances in terms of the instance versus delivery packaging, because they might say that this onboarded package of a network function is dependent upon this resource operator package. And therefore, then we have to join up the runtime instances with that at runtime. So there can be some nuances to this. But how that all gets tied together, right now it's still magic. There's no specification that does that. That's the big gap.
So, to follow on with that, though, is that, we're talking about, if you look at the specifications today, right? If you look at the DMS specifications for Kubernetes, is basically based upon a Kubernetes API with its, control plane and stuff like that to use to deploy a network function. But it missed as David said, missed definitions of how do I, when I deploy it, how do I monitor that workload or that NF in those sites? What is the configuration specs for the cloud-based stuff, not the application piece, but certainly the cloud-based stuff that's there. And so there's some concepts that Nefio has that are missing right now in the specification realm of ORAN, and that's the intent-based aspects with the CRDs and the operators for deploying and maintaining that ORAN network function. That's something that we'll have to add, right? Either both in the specifications as well as in the open source community. The other, in order to do it at scale, within Nefio community, as Tal had said, it's a declarative intent-based interface, right? So we've got to create these particular intents for particular network functions in order to monitor them. The other thing that's missing is really, and it's the elephant in the room at scale, and Tal talked about it, is with configuration of data. And how do we deal with the application configuration that is done imperatively now within the specification sets as well as within the architecture, and how do we move that such that it can be used at scale for utilizing the configuration of data approach that Nefio has. And I think that's our second challenge when we're talking about actually deploying these network functions. If we can solve those two things and feed that appropriately back into the standards for the APIs, I think we've done a real service to opening up the RAN.
Just to extend on what Tim was saying also is that the part that actually runs in the SMO as a configurator need not be limited just to the cloud configuration of the thing. We apply similar principles that, as I understand, just this morning, about how the process works and stuff, is that it's very advantageous because the data elements, the configuration elements for the O1 at the application layer, not the workload layer, but at the actual application layer, follow a similar pattern or path. And so if we're also treating the configuration of the application as a data set, it may also be better at scale, because today, as Tim said, even the NF instances are managed as pets. And it's not just the instances, the operations team think that the hardware it's running on is their hardware, but we're trying to decouple that and put it into a cloud, but they still say, no, well, I own that server and I should be running on that server. And that's just not the way it should be working in the cloud. You should be running on a server at scale. So we've got some shifts that have to happen in terms of way operations looks at it, but it's going to start with the standards of saying this is how it's done, so we can describe to them what that shift means to them, because right now it's conjecture without putting it into standard.
Yeah. I see this as a continuous evolution. You know, this curve of you having a feedback loop of what should be coming back to standards. That's what OSC was all about, right? ORAN-SC is all about that. So I think this is a great consortium where we are seeing the constant feedback loop that can go in. In fact, as I said to you before, instead of working in silos, we coming together, the biggest advantage that I see is this constant feedback loop, which can actually go about how these things can go back to standards and then implemented back into OSC to talk about the ORAN specifications to be there. So that is something which will be a great move to start with, and we are accelerating it with all these things coming together for sure. Again, it is actually multifold advantages. I can see that. One is, of course, having the free 5GC and the OI, both of them having specific goals being achieved or looked into, and accelerating that from the Nefio perspective. Also, the same happening on the OSC side, where the enablers of Nefio coming into the SMO part of it, and then providing us at least for the, I would not say the complete problem is solved there, but at least parts of the problems, right, to start with. The K8s profile part, I can say, to start with. So that is something which we can actually look forward to, where the feedback loop actually goes. And then that goes back to ORAN, the work group 6 to start with again, where I can see Udi there, of course, with Tim and Udi and David here. These people can actually take it to the specification group that can come back to the infra part of it and see how we can actually do this. So the entire cycle is actually something which we can actually accelerate and work together with all these collaborations. And that is what is a really exciting factor, which is the intersection point of all these things which I see into.
Yeah, I should have mentioned it in the, sorry to jump in, but when we talk about our relationship of OSC with ORAN, one of the things that we do a lot of is we do more explorative work. We do things beyond the spec or in the concept of the spec as it's being written, but sometimes in advance of the actual specification publication. And this is proven, all the way back with our initial, first 3 releases of OSC to be beneficial to the ORAN Alliance itself, in the fact that we can tell them when a specification can't be implemented as they specified it. We can also say, these are alternative ways, these are better ways. And this is where our colleagues from Red Hat have joined now OSC. I hope I'm not spoiling any thunder here. And they're going to help us in terms of that. They have an initiative in ORAN for the declarative IMS. And we're interested to see how that works out, because that could drastically affect the IMS development to have an alternative implementation, or to converge it to so it still is a standard that supports multiple mechanisms. So we're really interested in seeing how that comes out, because we think there's a feedback loop that's needed into the specifications as a result of that work.
Yeah, thank you, David. Actually, I was getting to that, which is exactly what you just said at the moment. We are interested in those declarative interfaces in terms of particularly the O2 IMS, and also interested in sharing our experience in terms of deploying cloud in different types of environments, both network functions and IT workloads. So, but I wanted to throw a little bit of a monkey wrench into the conversation here. And, the statement that you made about magic, and talk a little bit about that magic. At one level, do we really care about the magic as long as the outcome is satisfied, right? At another level, what detail of the magic do we need to actually define as part of the specification? I think there needs to be a little bit of a balance in the two, because when you actually define the right outcome, meaning your desires to place a workload on a given set of nodes in a cloud model at scale, then there are tools and mechanisms and levers to make that happen. There's affinity, there's machine config pools, there is Kubernetes profile, and now with the CRD. So there are ways you can actually achieve that. Now, do we need to actually be completely prescriptive of that entire methodology? I don't know. I don't think the answer is yes on that one. Absolutely. So I agree with you on that one. But we definitely agree 100% that we need to have a deterministic outcome, not a non-deterministic outcome. Perfect. Thank you.
Okay. I think there was a question, but maybe we leave it to the end, because that's what we planned here. I'm going to try and merge 2 of Cyrus' questions here in the interest of time, because we are running a bit over. They're about service assurance. So basically, what are the difficulties today in service assurance in the operations of ORAN network functions? And how can Nephew address service assurance capabilities provided by OCloud, SMO, RApps, and XApps?
I'll start, and then let the experts chime in. Okay. The way I look at it is that there's a certain amount of customization. Every network function is not only the function unique, but the implementation from a given vendor is unique. Every cloud that we deploy, Wind River's OCloud versus VMware's OCloud, are still different implementations. They might not even use the same physical hardware. In fact, it's likely that we buy at a telco because the vendors that we select have integrated or tested with certain equipment. And so we are likely to require our cloud provider to deploy those equipments where we expect to deploy those applications. And so as a result, we have this very versatile environment of differing hardware, differing software, but the SMO layer needs to remain calm and constant. And that's the challenge. That's ultimately the challenge, is to do that. And where I see these Nephew coming in is it provides the ability for us to extend both the SMO and the cloud with specifics to address those concerns, so that we can, remain, even though the duck is paddling like crazy underwater, it looks like it's just skimming across the pond.
Yeah, so, with respect to that, if you look at the problem of service assurance, it's really first asking the question, what do you want to assure, right? What am I trying to assure, right? And that could be different. That's a different answer depending upon what you're talking about, the what. Are you talking about the cloud infrastructure? Are you talking about the workload? Are you talking about the application? And then the second question you ask is, say, hey, where am I providing this assurance, right? And is that in the actual cloud? Is that going to be up in the SMO layer? So there's the stack layer that we talked about yesterday with the gentleman that was speaking about working group 8, and he's talking about the full stack. And then there's also the location of those places. And so it's a multi-dimensional problem, service assurances. And so there's aspects of service assurance that happens at various places, whether it's within the network function, within a cloud site, within a global site. And so we have to have the appropriate lever or appropriate enablers at the correct level that enable the assurance. And that first starts, and we've had these discussions in Nefio. So there's a working group within SIG1, it's called Service Assurance, that's looking at this problem. And we recognize, even within Nefio, that we first got to start with observability. I've got to be able to provide, as David talked about, even for AI/ML, I've got to be able to provide the data in order for the service assurance loops to work on, right? And so there's an observability framework that's in there that they're working on first. So, and then there's the assurance, the closed loop aspects of it that can utilize this data. And so I think the challenge will be that when we talk about service assurance is first, how do we deal with that observability framework, you know? But it's a multi-dimensional problem. It's not just can't be solved by the SMO, can't be just solved by the cloud. It's got to be a collaborative approach between the two, across those dimensions.
Okay, so maybe we'll move on to the last question, which in some sense is the spirit of this workshop here. What role should each of the open source communities, so OSC, Nefio, OAI, and ORAN, play to collaboratively achieve the goal of deployment and management of the ORAN network functions? And this will conclude the panel basically, and afterwards we'll open the floor to the audience.
I can start very quickly. I think, look, reference implementations are key. Reference implementations provide learning in terms of how things are being done in the real world. So the work that OAI has done so far in terms of creating the 5G core work initially and then the RAN work subsequently, and the work that Irfan, Raymond, you and I started, I think, 4 years ago, in terms of proving the concept of 5G on an open stage, was critical in terms of where you are today with respect to developing the OCU and the ODU high with partnership in different companies. Again, I think David actually mentioned it earlier. It allows you to learn and provide feedback into the specification model. So I think the more we can actually double down on this kind of work in terms of providing that rough consensus running code will help us be better overall in terms of defining better specifications and overall better interfaces and better standards. That's just my 2 cents.
So the way I look at it is that if you look at the ORAN architecture, it's really divided up into 3 distinct layers. There's the application layer, there's the management layer of those applications, and then you have the cloud. And so there's 3 distinct layers, and there's a role here that that is focused on for the different organizations. OAI is clearly in the network space. They have more network functions, things. It doesn't mean that they're going to be the only place you find network functions. Likewise, I think in the cloud, Nefio is all about the cloud. How do you use it? How do you best take advantage of it? How do you manage it? How do you manage things running in it? And so clearly I see that there's that space in for Nefio to focus on contributing back into ORAN about the cloud. And for us to use that as the pillar, if you will, for development, which means that if we're doing work like in OSC for the cloud, we likely need to work closely with Nefio because they are also working in the cloud. And we do a lot of the infrastructure, whereas I think Nefio is more in the software aspect of using the physical hardware. And so there's a place for that. But then we get to the management, the SMO, and we have in OSC we have a large focus on the SMO. Half of our projects are related to the SMO. It's big. If you actually look in the architecture diagram that was at the beginning of the presentation from this right here, you see that, well, you have the IMS and the DMS down here at the bottom in the cloud. That's mostly your software things. You have the network functions. The rest of that whole diagram is all SMO. So there's more moving parts in the SMO than there is actually in the RAN itself or in the cloud. And so the SMO is a very complicated thing. And so having a focus on that, I think, is one of the areas. And that's actually one of the reasons that when we had our PTL need and for a new PTL for the SMO project, the reason we actually selected Seshu was the fact that he came from a multidisciplinary background. He has direct knowledge of ONAP, which is a large part of our SMO implementation leverages. And he also has Nefio knowledge. He also had hooks into several other open source projects. He's not just those three, but that gives us a broader view for the SMO, and that's what it needs. And so that's why we voted Seshu into the PTL position for the SMO project as a whole. The tying thing for this, though, I think, is that we need to make sure that as we go forward, that we are very collaborative in terms of the work. And by that, I mean that minimize the amount of upstreaming and downstreamings we have to do between the organizations, instead do the complementary work. If we can, the timelines will be the dictate. But if we can, in the native organization that would host that software. That way we minimize integrations or things that we have to do. It'd be better if we can use component parts as wholes and manage the CI/CD process by deploying a whole new component rather than having to do some form of a code refactor when something changes and do it, because that just will slow us down. And the goal here is to expedite and speed up the realization of ORAN, not slow it down.
I think first of all, you can see my shoulders have drooped down with so much work on my shoulders right now. Thanks a lot, David. So hope I return to India.
Our whole future depends on Seshu.
I hope I go back to India in one form and shape. That's one thing for sure. I'll try to make it. Thanks a lot for the trust, by the way. Yeah, I want to add to the other point. I mean, we talk about standards and all. Again, guys, I'm a guy who is low-lying again with hanging my hands dirty when it comes to code and all. So for me, code matters a lot, for doing all these implementations and all. And from that perspective, what I can say you is, in fact, me and Tim were having a ear bite here, that specifications should be, end of the day, specifications have to be defined. We cannot completely differ from that. You're required to actually have those plug and plays or those unique values of it, which cannot be differed completely and have haywire over there, or we cannot go hazy on that part. So what is critical for me is the feedback loop, which I was talking about and follow. I mean, that's what is reckoned by David and Azhar by also sometime before. The critical part here is to make sure that we use those components as it is. Nefio, again, with all due respect, I want to tell, is not just built for ORAN alone. It is built for multiple other things, ORAN being one of the use case of it. So that's how we treat it. We should treat it that way, So I know we are talking about ORAN here. So let's take that integration part, which is actually coming from out of Nefio, which is looking into the ORAN piece, which is what should be our main focus. So getting a constant feedback loop from Nefio into the OSC and going back to the ORAN Alliance as a work group is critical. That's something, I think that's how the flow should be. And at the same time, we should also make sure that we evolve the OSC group modules which are being there, because that is actually a key focus of ORAN, right? That should be a focus. So infrastructure project, the RIC project, and the SMO projects of the ORAN should also learn from this feedback loop and get evolved as we evolve the spec. So that's how the full feedback loop should be. And then Nefio on the other side of it, it's a use case for realization, for proving the points of what Nefio is coming from. ORAN is actually accelerating that part of it. ORAN is going to enable that part of it, saying that, yes, these parts have been proved in this use case. Other use case of telco can be applied henceforth and taken forward. So that's how I see it. And I want to be sure that this integration points, which we see here is part of this, have to be clearly defined, and they will be evolved. I mean, I'm sure they will evolve as we talk more about it. And that is what is exciting for me also, because being part of all these pieces of it, I'm sure that it's a lot to learn. There's a lot to collaborate and lots to have merry around. Looking forward for that.
So let me just summarize what the other three gentlemen talked about was the fact that we have domain. This is a big problem, right? You know, ORAN is not a simple problem, right? And it's going to require disciplines from various domains and expertise from various domains, right? And so that's what, and we need a reference design that works for this at scale, right? That's what the first gentleman talked about, right? And so having OSC and OAI work in their domains and Nefio working in their domains. By the way, you know, you talked about Nefio being in other industries. We've had these talks in Qualcomm that said, hey, dude, if I've got to do, you know, automotive, you know, functions, and I got to do that at scale, why can't I use Nefio for that? So we're having these conversations even within Qualcomm for various other industries that we're interested in. But for the ORAN, you know, the fact that we can bring together these domain expertise, we honor the interfaces of the specifications, and we allow these organizations to do what they want to do in a collaborative fashion, and do what they do well, I think we'll be successful. It was something that we looked at it from Qualcomm's perspective. We looked at it as we take these individual pieces, put them together, and it creates an ecosystem that I think can be very alive, right?
And I just take one more minute to just talk about analogy, which I heard in IMC. And some of you were also there in IMC, India Mobile Congress last week, where they were talking of ORAN. One great analogy which came from Rajesh Singh of Vodafone Idea was that ORAN is that Chinese bamboo tree, right? So initially, when you plant it, you don't see anything on top of the ground. Actually, everything goes down. So that is where we are right now, and this points of getting Nefio into it, OA into it, and free 5GC with supporting that core part and OI supporting the RAN part of it. This entire thing is where it's happening under the ground right now. So surely we'll actually have a point where we'll see movement on top of the floor, I mean on top of the ground, and once it starts, there is no, it can be clearly visible even with eyes, right? The way I mean Chinese bamboo grows and all. So I'm sure that is where we are, and this is the right time to start off and accelerate this entire thing. I'm using the word accelerate a lot of times because that is what it is actually. Otherwise, I mean, we know last few years we have been working about it, going back and forth on this. We thought this collaboration is going to be really, really tough, and with this collaboration, I can see that we are in the right track. Looking forward. Thank you.
Thank you. Okay, I think we have time for a couple of questions. You're all very patient, but there was already one before.
I have one question regarding the idea of this vendor lock-in. Basically, the operators don't want vendor lock-in. I definitely understand the value of vendor lock-in from economic standpoint. Every vendor wants to have a sticky thing in the customer thing, right? The customer network. That's the only way they make money. But now the operator has everything. The operator is really paying for the cloud. The operator is paying for the RUs, DUs, and everything. Now you have reference architecture. What is preventing the operator from actually putting a small team, internal team, and owning that piece? You know, that way you don't really have to, you never have to worry about vendor lock-in because you actually own that piece to basically build your own kind of value proposition.
So I can talk as an operator. That this is exactly how we're organized today. That we have teams that are dedicated to the technology and its implementation. Okay, and we have some that are dedicated to when we've moved at AT&T a lot of things onto a cloud, and yet the team has to be specific to that cloud, and so they have nothing to do with the application. So even internally, yeah, it's all in the operator, but they're totally different teams. And as a result, then we wind up with a lot of teams because each one is now different. And the interoperability that then occurs also has to be put in place. And we wind up with experts on vendor A that can't operate for vendor B because of the fact that they only know the specific metrics, values, KPIs, alarms, conditions, probable causes of that solution. And so there's no way for them to have a standard way to be able to pull in a different vendor's data into a common arena and be able to view them side by side or in place because today they're vendor A, but tomorrow they're vendor B. And so as a result, we wind up with these lock-ins. And that really not only hurts us as a business model, okay, because of the fact that we have to have specific training for the individuals, but it also hurts us from an economic perspective, is that to shift, it's a complete rip and replace and complete retrain on there. So to move from vendor A to vendor B is a huge, huge cost to us. And so, and yet we find at times that it would be nice if we could just use this piece. Like, for instance, we find that in this particular scenario, it would be very nice if we could use one vendor's radio, but don't give up our core processing, our DU or our CU processing that we have in place to use that radio. And that's just because that particular radio has specific advantages in the environment that we're going to deploy. But the interoperability comes into question. So it's not just about not being vendor lock-in. It is also about opportunity for mix and match, for best of breed type of a thing for the specific situation. But we're so caught into this lock-in mentality that we plan for obsolescence. So for us, Kubernetes is the current thing, but we expect that between now and 6G or 2030, there might be something new that comes out that's better than Kubernetes today.
Yeah, the only thing I'll say is I do have a couple of slides as part of the presentation on exactly that topic in terms of what lock-in, where, when, why, and I can answer that through that particular presentation.
We should move to that. We're running out of time. So one final word, please. Okay.
Okay, well, thank you very much. That was a very informative panel.